Hello, today's topic is multiplexer. This multiplexer is very important topic in digital electronics. The basic definition of this multiplexer is it belongs to a combinational category or combinational circuit which has several input data lines and single output data line. That means a multiplexer is a digital switch. It allows digital information from several sources to be routed onto a single output line. The basic multiplexer has several data input lines and a single output line. Okay, so that means a multiplexer has several inputs and single output. Let's see here. It is a combinational circuit which have many data inputs and single output depending on control or select inputs. Among these several data inputs, for every combination of a control or select inputs, one of the input is going to be selected and transfer that source information to the output. Let's see. It is a block. A combinational block has several inputs and single output with certain select lines. Now, which has several inputs, let us take these several inputs are capital N. Several inputs are capital N, and which requires select lines are log small n base 2, and which has single output. Let us assume the output is Y. Okay, this is little difficult to understand because we are taking capital N here and the select line is log of small n base 2. It is difficult to understand. Let's see the another definition here, that is which has 2 power n input lines, which has 2 power n input lines and with a n select lines. So which has 2 power n input lines and n select lines and a single output. It is easy to remember this one because the input is 2 power of small n and the select lines are small n. And the multiplexers are also known as data selector, parallel to serial converter, and many to one circuit. You see here data selector. Data selector is nothing but of, here we are having different inputs. Input number 1, something like input A, input B, input C, input D. This input may be either 0 or 1 or anything, whatever it may be. Among these, every time it is going to be connected to one input. That may be one time it is connected to the A and transfer that A information to the output. One time it is going to be connected to the B and transfer the B information to the output. One time it is going to be connected to the C and transfer the C information to the output. So that it is called data selectors. So I am going to selecting the data of a particular source, either A, B, C, D sources, and transfer to the output. This selection is based on the selective lines. So that is, it is called as data selectors. Parallel to serial converter. Parallel to serial converter. Here we are having multiple inputs and the output is single. So it is called as parallel input, serial output. And it is also called as a many to one circuit. The input is having many inputs and the output is having one output. So these are the different names for the multiplex. And let's see the basic block diagram of a multiplexer. Here I am considering an example, that is 4 by 1 multiplex. It is a 4 to 1 multiplexer. For 4 to 1 multiplexer, which is having 4 inputs, that 4 inputs are I0, I1, I2, I3, and I am having single output. To control the 4 inputs, I am going to use some select lines. Now let us decide how many select lines are required to design 4 to 1 multiplexer. I am going to arrange the 4 number into 2 by 2. I am going to arrange 4 into a number like 2 by 2. So it looks like 2 by n combination, right? It looks like 2 power n combination. So what is small n here? 2. So that it requires 2 select lines. These 2 select lines can be arranged in 4 combinations. Those are 0 0, 0 1, 1 0, 1 1 combination. Okay, 2 select lines can be arranged in 4 combinations. For every combination, the multiplexer is going to be connected to one of the source or one of the input. Here the sources are I0, I1, I2, I3. Let us take, if both are 0 0, S0, S1 both are 0 0, which is going to be selecting I0. Whatever the data is there at the I0 terminal, here it is having some data, either 0 or 1 or anything number that can be transferred to the output by selecting S0, S1 is 0 0. And for the second combination, select line combination is 0 1. For 0 1, it is going to be connected to the I1. Whatever the data is there at the input of the I1, that can be transferred to the output. Similarly, 1 0 is connected to the I2, 1 1 is connected to the I3. Like from several sources, the data is going to be connected and transferred to the output. This is a block diagram of a simple 4 to 1 multiplex, and this is a truth table for that multiplex. Now based on the truth table, you just implement a final equation. There are 2 ways to implement the equation. One is sum of product form, the other one is product of summation form. So to implement a digital circuit, we need De Morgan's laws, and also we need conversions, that is from sum of product to the product of sum and product of sum to the sum of product. By using De Morgan's laws, it is possible to convert. So this equation is nothing but a sum of product. Most of the equations are in the sum of product. If the sum of product equation is very complex, then you can go for the product of sum combination. Okay, and in the sum of product combination, each bit can be represented like, if it is a 0, so you can write whatever the number can be representing, like S0 can be representing either 0 or 1. So if it is 0, instead of S0 you can write S0 bar. If it is 1, instead of S0 you can write same as it is S0. In the SOP format, S0 can be arranged in 2 combinations, either 0 or 1. If it is 0, S0 can be represented as S0 bar. If it is 1, S0 can be represented as S0. Similarly, S1, if it is 0, S1 can be represented as S1 bar. If it is 1, S1 can be represented as S1 bar. So like you see here, the equation y is equals to, we are having 4 combinations here. That is, the first combination is 0 0 I0. What is this? 0 means it is sum of product. S0 can be represented as S0 bar. So S0 bar dot, and S1 is 0 again, S1 bar dot, I0 is I0. We don't know what is I0. I0 may be either 0 or 1 or any other combination. So I am going to consider like this: S0 bar, S1 bar, I0, S0 bar, S1 bar, I0, plus here the S0 is 0, so that I am going to consider as S0 bar, and here the S1 is 1, I am going to consider this as it is because it is 1, and I1, plus third combination is 1 means S0, 0 means S1 bar, Y means I2, plus the last one is 1 means S0, 1 means S1, Y means I3. This is the equation for 4 combinations. Based on this equation, you can implement the internal structure. Based on the equation, you can implement the internal structure. That internal structure has several inputs. Those are I0, I1, I2, I3, and select lines S0, S1, and single output. I am going to assuming the output is Y. Now it is the sum of product combination. The output Y is equals to the sum of product. So first you have to find the product value, then you can sum it. And you see here it is having S0 bar, S1 bar, I0, S0 bar, S1, I1. So that what I am going to take here, the S0, S1 as two select lines, which is having complement of that two S0 or S1. That means, so I am going to take one inverter here to find the complement of S0. That is, the complement of S0 is S0 bar. The complement of S1 is S1 bar. Okay, now you see the first AND gate, which is going to be connected something like different locations like this, these 2 points. One of the input is connected to the S0 bar, and the I0 is connected to the input, and the S1 bar is connected to the input. So the output equation is S1 bar into S0 bar into I0. Okay, and now let's see the second gate. The second gate is also having 3 inputs which are connected in different locations. This location is S0 bar, and the second input is I1, the third input is S1 according to your second input equation. For the third gate is connected to the three inputs. These are the locations, these are the points where it is connected to the input of third gate, that is S0, I2, S1 bar. Similarly, fourth gate is connected here, this location, that those are S0, I3 and S1. Finally, these all inputs are connected to the Y. That is a final equation. This is the internal structure of 4-to-1 multiplexer. To design a multiplexer, first you have to find the rough block diagram of that particular multiplexer, and based on the logic of that particular multiplexer, you make a table, truth table. Based on the truth table, you find the equation, that may be either sum of product or product of sum. Based on the equation, you just implement the internal structure of 4-to-1 multiplexer. If it is the 8/1 or 8-to-1 multiplexer, it follows the same rule. So for 8/1 multiplexer, which has 8 inputs, 8 inputs can be arranged in 2 power 3. That means which requires 3 select lines. Those are S0, S1, S2. So now I am having 3 inputs, S0, S1, S2, that can be arranged in 8 combinations, so that it requires 8 inputs, I0 to I7. Based on that, I am going to find the equation, and based on that, I am going to extend the internal structure, right? And it is very simple. You practice it. Thank you.